Alright, Mr. Solis for AQR here. We're going to be talking about this next sheet. If you notice, instead of Houston, now we have Philadelphia right here. This is part B. Of course, this is still length of daylight, but we're looking at part B for this. And I need to go over a couple of things to go ahead and actually do this stuff. So as you can see, the data is a little bit different. We have all this different stuff right over here. And when we create our scatter plot, we create something that looks like this. There it is. Oops, upside down. There it is. And you can map this on top of the other data. If you noticed, I used little X's rather than using just dots to go ahead and map this data. So now you can see this as it comes. Now, what they're asking us to do here is to enter in the data into our calculators. So, as you can see, I have a calculator right here. This is the original data for Houston. You can actually see that, it's all Houston. And of course, I don't have the formula right here, but I'm going to be entering that in quite shortly. This takes only a few seconds. Entered into this thing, and you can see that's what the formula is, what I got here written. Of course, remember that this is the calculator form. This is the what we call the factored B form, and these are all my data points right here: 170, 841, June 19th. You're probably wondering about that. 14 hours 1 minute. And just to show you how quickly how to do that, what I did is I took the date. I could actually use this chart. I took the fact that I have this for the day 170, and I just look at this chart. If I look at the chart and look for numbers close to 170, I have 152 and 182. So I'm going to go with the smaller one, and I take 170 minus 152. That gives me 18. That means 18 days later. That's the date we're looking at. 18 days later, if this was on June 1st, I'm just going to add 18 to June 1st, so the 19th. That's how I got June 19th here. Then for the 14 hours 1 minute, I just went ahead and did this. It was 184 minutes. I divide that by 60. That gives me 14. I'm going to subtract the 14 because now I know it's 14 hours. And I multiply that by 60, and that gives me 1 minute. 14 hours, 1 minute. That's why I have it written down here, 14 hours, 1 minute. Now, just going ahead and seeing how everything else is. This is new data. We're going to actually have to plot this, just like we plotted it here on my graph over here. Now I'm going to have to go ahead and plot this data here. Now this data for Philadelphia is different from Houston. So I grab my trusty calculator, go to Stat, Edit, and if you notice, now I have data in L1, L2, and L3. Now this is the Philadelphia data. I need to be using this data, but I also want to still keep this data over here. Now if you're probably wondering, how am I going to go ahead and hit the scatter plot? Well, I go ahead and do this. Second, y equals. That brings up this menu. And I already have plot 1 on, and it says L1, L2. Now I'm going to be using plot 2, but I want that to change from L1, L2 to L1, L3. Now I have it in here in this plotter. As you can see, I bring it down. That's what I want. There's L1. I want to change this to L2. So second, and if you look down here, you have these blue marks. This has L1, L2, L3. So I want L3. And now, L3 is there. I'm going to go ahead and have it entered that. Just hit enter just to make sure I go to the next line. Now when I go to graph, whoops, I don't want to do that. And I'll erase this for now. Don't want to see that right now. If you see that, the plotter is not on. I need to turn on the plotter. I forgot to do that. Next time you do this, you hit second, y equals, go down to plot, turn on plot P2, plot 2, just to make sure it works. And everything is right there. So now I'm going to graph. And it doesn't look very good. I can't really tell. So I have to hit zoom 9. And there we go. Now you can see your data. It's a lot better. It looks similar to what we have over here. Not perfect, but it does work. All right. Now, here comes the tricky part. I'm going to hit this right here. I'm going to enter in the formula that I had from yesterday, just to make sure I have that in there. Should have skipped that whole thing, but oh well, happens. 1, 1. Alright, and just making sure that this works. There it is. And it is working. So what I'm going to do, I'm going to go ahead and exit out of that. I'm going to do another sine regression for this. So I hit stat, calc. I already have the data for L1, but now I have to do it for L2. So there's sine reg. I want to choose sine reg. You guys know this. So enter, and it brings up this screen. So iterations 3, that's fine. It says xlist L1, which is just fine. We want to go ahead and use that, but it says ylist L2. So I need to go ahead and change that to L3. So if you remember, what you do is you go ahead and hit the second button. Then you go down here and you find where it says L3, right there. It says L3 right there. Now, as you can see, now it says L1, L3. I'm going to go ahead and just go to calculate this. It's going to take a few minutes. And there it is. All done. And we're going to write this out in first the regular form and then the factored B form. So I'll bring up my paper. Let me go ahead and change this a little bit so you can actually see me writing this. So grab this. So 168.44 sine, that's 0.017 x minus 1.29. It's a little bit different from the other one, plus 726.06. And so we have that. That's the calculator form. Now we need the factor B form. So what I'm going to do in factor B form, I'm going to take this, I'm going to divide both of these by 0.017, and it's going to be factored out. So 168.44 sine 0.017, open parentheses, x, minus, so really all I need to do is just take 1.29 and divide that by 0.017. So 75.88. Close that. Close double parentheses. I'm getting into my lines, but that happens. Plus 726.06. So there's my factored B form. Now you're probably wondering about ordered pairs and all that good fun stuff, all the date, and that's really easy to do too. So let me do that really fast. Okay, hopefully I entered everything in correctly. Hit that. And it fits my data, yay, I did it correctly. Alright, so if we take a look at the instructions on what they were asking here. They're asking us to answer this. This is where we've basically done. We're done up to here. Connect the points. We're going to do that. You guys will do that on your own sheet. How do the regression models compare, you know, to Houston, Philadelphia? Just write what you see, similarities and differences. Use your calculator to determine the maximum minimum values. We're going to be doing that. So let's go ahead and do that for Philadelphia, maximum minimums. So we're going to leave that over there for now. So I need my calculator. Calculator does this really simply. So first off, I have to use second calc. And it has the two functions, max, minimum. So maximum, and I need to make sure I'm on the right graph. So right now I'm on the wrong graph. I need to go to that graph. So I'm going to push up. There it goes. It's right there. So I need a left bound. So I'm going to pick a point to the left of the max, hit enter. Then I look for a right bound. I'm going to go ahead and look for a point to the right of the max. There it goes. And just push another enter, so that way we find this. So it gives us this data, 168 and 894. Actually 95. So 168, comma, 895. And with another parentheses. I'm going to come back to date in just a few minutes, just to go ahead and, I just want to get my maximum minimums. So I'm going to get my minimum now. Do the same thing, but this time with the minimum point. Calculate minimum, which is 3. I'm going to go ahead and find a point. Oh, I'm on the wrong graph, so I need to go to the next one. So I'm going to look for a point after that. So as you can see, it's down here, all the way down. Hit enter. Go all the way to the right. Hit enter again, and push enter. And that gives me those 2 points. Alright, so as you can see right here, my calculator calculated the minimum, which is 352, comma, 557. Well, 558, right there. So for date, all I need to do is really look at the date that it says 168. Well, I go down here, find anything between 168, so 152 again, so this is still in June. So this is June. So 152, so 168 minus 152. 16, so 16 days, so this is the 17th, so it's June 17th. And then for the length of day, I'm going to get 8. Not 895? Yes, it is 895. Best thing to do is just divide by 60. That gives me 14 hours. And for the minutes, I just subtract the 14, just the whole number, and multiply it by 60. And that gives me 55 minutes. Next one, I'm going to do the same thing. That's right here, 352. So that would be sometime in December. So 355. So 352 minus 335. Or is it 35? Yeah, 352 minus 335. 17. So 17 more days. That's December 18th. Now, length of day, we have a couple of things. We do that. 558 divided by 60. That gives me 9 hours. And we take, subtract 9 and times 60. That gives me 9 hours, 18 minutes. Real interesting. Now, there's an extra thing. It says first intersection and second intersection. So we want to get those intersecting days. So that's really easy to do. And this is actually part of these things right here. Use your calculator. Doesn't matter. Oh, that's a question right there. So let's see. Determine the intersection points. That's number 9. Determine the intersection points. So this is actually really easy to go ahead and do. So I'm going to go ahead and go back to my graph. I'm going to hit a trace. I just want to move my cursor. You can't really see it here. Wow, it's weird. Well, let's not worry about it. Second calc. I'm going to do intersect. So it says first curve. And as you can see, the cursor is all the way on this side. So I'm going to move that all the way over to the right because I want to get this intersection and this intersection. This is the first intersection. This is the second intersection. So when I get close to that intersection point, that's close enough right there. As you can see, it's right about there. I'm going to hit enter 3 times. And there it is. It says 73 and 718, or actually 719. 73, comma, 719. I'm going to get the date and all that later. So let me do the second one first. So second calc, intersect. I'm going to go ahead and let that go all the way over here. Remember, this is the second intersection. There's the first, second. These are actually very important days in the year. All right, 1, 2, 3. And there we go. 255, comma, 742. Now, I'm going to look at the day. 60 would be the lowest right here. So we go ahead and do 73 minus 60. That's 13 days. And let's see, that was in March. So this is March 14th. The next one, I'm going to get that day. I'm going to look 255. Well, 244 would be the next one. So 255 minus 244. It's 11. And that's in September. So September 12th. You're probably wondering why I'm adding an extra day. It's probably because it's the fact that right here we have this day. And we're doing it up to that day. So we have to add in a day for everything. Because they always take these measurements of the first of the month. So 719 divided by 60, that's 11 hours. Let's see, subtract 11 times 60, that gives us 59. So 11 hours, 59 minutes. And then on the other one would be 742 divided by 60, 12 hours. And let's see, subtract 12 and multiply by 60, 22 minutes. Very interesting. Why are those numbers so close? There may be something to that. Oh well. So you guys are going to be answering this in class. You have the reflection, you have all these ones. So you're going to be answering, or basically doing, 1 through 14, and you're going to go ahead and turn that in at the end of the class. So here we go. I'm going to go ahead and sign off. This is Mr. Solis from MrSolis.com, and take care.